Hey there guys, it's Chili. Welcome back to Beginner C++ Tutorial 3. Now I got some real meaty topics for you guys today. We're going to be covering the if statement, which is just a way of making decisions in your programs, and we're going to be covering something called a boolean variable. We're also going to look at keyboard input. But first, as usual, we have the homework assignment. So let's look at the solution to that. I'm going to build it. And you see here we've got our reticle in the bottom right hand corner. But if I change some of these numbers, we can see that the reticle moves. Well, it didn't move that much, but for example, let's make them negative. We can do that because ints hold negative numbers. It's all kosher. We do that, and let's and we offset our pixel in the negative direction of x and y by a lot, and now it's up here. Good stuff. And the way we do this is quite simply the same way you did it in the last homework. You apply the same operation to each pixel. You add the same x value and the same y value. Only this time, instead of adding it by hand by changing the literal numbers, you are adding it using a variable, and then you're setting the variable here in one spot. Changing these two values here will change where the pixel is on the screen. Neato. Now, one thing that bothers me about this solution here is, well, let's say we plug zeros into dx and dy. I choose the name dx and dy because it's a displacement. We're moving the image by this amount in the x and the y directions. So we choose 0, meaning we're not going to displace the image at all. And it's here. So this is the default position, the base position of the reticle. But why here? Why choose this number as a default? Well, basically because that's where it was at when I wrote this code. But that's not really a very good reason, is it? Generally, we want to have reasons for the things we do in programming. Now, instead of basing our reticle around the position 700, 500, what if we based it around 0, 0? So we'd have to do something like this. And if we build and run this, I've already built it, let's run it. We get our reticle up here in the top left-hand corner at the position 0, 0. Close that. We get a problem here. Basically, the problem is, of course, if we're drawing at 0, 0, half of our reticle is going to be off the screen, so we can't really draw at 0, 0 anymore. We want to draw somewhere. Basically, if we base our reticle around the position 0, 0, now whatever number we put into dx and dy, that becomes the position of the reticle. So if we want to put the reticle at the middle of the screen, we just put that coordinate into x and y and it goes right where we want it to. Much better than putting it at some random place and having to do some bullshit math in your head to try to figure out what values of x and y you need to get the reticle over there. No. Base your, it's pretty common to base a model or a sprite either around, 0, 0, or the top left-hand corner of the sprite, whatever. But anyways, now that we're basing our reticle around 0 instead of around some arbitrary position, these dx and dy, they don't really mean the displacement from a base position. What they actually mean in this case is the actual position of the reticle. So we can change this dx and dy to just x and y. And I'm going to change all these, but I'm going to show you a little trick here. Press Alt and drag up like this, and you can select more than one line like this. Press space, you can move them all over like that. So I'm just going to alt drag. Let me just try this again here. Alt drag up here. I'm going to line that up there. Wait, I got a plan here. Just wait. Fuck, no. That wasn't alt, that was the space bar. Don't press the space bar, apparently. Press Alt. And we're going to drag this, and holy shit, I think the world might be actually ending. This might be the apocalypse, people. All right, so now I've got these dx's and dy's lined up. Why did I do that? Well, I'm going to alt drag the whole line here, press delete, and I've just deleted all those d's all at once. I'm the dong smasher. I'm the D smasher. There we go. Beautiful. So I just showed you a little trick. You press Alt, and you can select like a rectangular region of text, and just like fucking put a bunch of shit in there. And of course, if we build that, works fine because, doesn't matter what you name your variables. But I just like to name it x and y now because it's actually the x position and y position of the reticle rather than just a displacement from some random position. And that's the homework solution. Now, one thing that I never really outright stated, but that you probably already guessed for yourself, is the order in which these operations occur, the order in which the functions are called. Every statement is called in order from top to bottom. First this put pixel, then this one, this one, this one, this one, this one. Well, actually, the first thing that happens is that these variables are created and initialized. But after that, yeah, you call these put pixels in order. Inside the put pixels, the order is, it's a little different story. First, you're going to evaluate these expressions, and then you're going to call the put pixel. But the order of operations inside of any given statement can depend on a lot of different things and can be pretty sticky sometimes. I'm not going to go into huge detail for it right now, but in terms of individual statements, they are executed one after another in a straight line like this. So in our program here, you see that it's the same goddamn thing every single time you run it. Every single time you create your X and Y and you call the put pixels with them. Same place every single time, unless you change the code and rebuild the program. But you see, ladies, real programs have curves. And what I mean when I say that is that, they're interactive. They respond to the user input and they do different things in different situations. It's not just the same thing running top to bottom every single time. So this is where branching comes in. Now, branching is not some kind of new sex move. It's what programmers call making a choice in your program. Think of it like a fork in the road. You got to make a decision. Left or right, boxers or briefs, pepperoni or, well, there's actually no choice there. You have to take pepperoni. Now, oftentimes when programmers talk about branching and flow control, they like to represent it in the form of a diagram. And those diagrams are called flowcharts. And basically, there are two main parts of the flowchart. There are the square parts, and those just tell you something that happens, some kind of calculation or action. And then you have the diamonds, and the diamonds are the decisions. These are the branching parts of the diagram. So you see here, we've got a decision here, a test, a check, whatever you want to call it, and you got two options, no or yes. And generally in programming, that's all you get. You get a no or you get a yes. There are no three options. You can build any kind of three option choice out of multiple two option choices, but we'll get to that later. So let's get right down to it and write our own branching code, shall we? Just type in what I'm typing in here. Fuck. Don't do that one. We're going to put a opening brace here and a closing brace here. And Visual Studio is nice enough to indent our shit for us. That's cool. So what do you think is going to happen when you build and run this? Make a prediction. You don't have to, rack your brains here. Just make a quick prediction and see if you're right. And nothing changed. Is that what you predicted? If so, congratulations. If not, who cares? Moving on. Let's change this word true to false and see what happens. Again, make a prediction. Cast your votes. Make a bet. And we get nothing. The reticle has disappeared when we change this true to false. Well, let me break it down for you. This thing here is called an if statement, and it basically has three parts. It has the if itself, and it has an expression here which controls the if, and then it has some code. So the if statement is controlled by the value inside of these parentheses. And this value isn't an integer. It's a boolean value, or a bool. And the difference between integer and boolean is integer, you have approximately 4 billion different values you can store. With the boolean, there are only two possible values, true and false. If the value is true in this if statement, then this code in the code block will be executed. If the value is false, this code is going to be skipped. That is how it works. These braces here, they tell us from where to where is the code block for this if statement. So they tell us what code is being controlled by the if statement. And that's generally the job of these braces here. It's to group code lines together or statements together into a block of code. Actually, you've been doing this the whole time, sort of, in the compose frame function here. Look, we got the braces here, and they group together all the statements that form the body of the compose frame function. I haven't talked about, creating functions and function bodies yet, but spoilers. Spoilers, he was a ghost the whole time. Also, roofies. So yeah, the if statement here allows us to specify code that is only executed if some condition is met. It's only executed if the value in here is true. Now, just like with putPixel, we started by using a hard-coded literal value, but we can also use a variable. So you can type in here const bool, because the variable is a type bool now, and we'll just call this cond for condition, not for condom, you freak. And we'll set its value to true. True. And then we'll put the variable inside here, cond. And if we build it, what is going to happen? Well, we get our variable in here because, of course, cond is true. So this evaluates to true, so we execute the code inside of the code block. Set it to false, and it disappears, of course. Fair enough. So big whoop, we can control this if statement by setting the value of this variable. We could have already done that just by, putting the value directly in here. And we don't even need an if statement. We could just delete these lines and we'd get the same effect. What's in it for chili? That's what I want to know. Well, I'm going to get you to type some code in and we'll see. So type in WND, that stands for window, dot KBD, that's keyboard, dot key is pressed. And we're going to put in here VK underscore up. All right. So const bool condition is equal to window.keyboard.key is pressed up. If condition, do this shit. So what do you think is going to happen? Build this program, run the motherfucker, and we get nothing. Now, what do you think is going to happen when we press the up button? Oh, we got a reticle there, and it's gone again. Push and it's there, release and it's gone. This is some kind of magic. Burn them at the stake. So what kind of magic do you think this is? Well, we got like some kind of name here, and we got the parentheses, and we got some kind of parameter in here. So, you might say, well, this looks like a function. And I'd say you're right. But you might say, well, shit, Chili, that's not a very good indicator because, this thing has, a name and parentheses, and it's got something inside, a parameter. It's not a function. This is an if statement. But the difference is, of course, if is a special word, and you can tell it's a special word because the IDE, the text editor, gives it a different color. So we know this is a special word. This is part of the C++ language. But this isn't a special word. This is just a symbol, probably defined by a programmer. So that's how you can kind of tell the difference between if something's a function or if it's maybe part of the C++ language. But anyways, so this is a function here. Interesting. Another hint that it's a function is because you got this object name here, and you've got the object, then the member access operator, the dot. So you got object dot something. That means that we're calling a member function. And you might say, well, chill, this is kind of weird. I'm used to graphics dot, but I'm not used to something dot function. That's weird. And the thing about C++ is you can put objects in your objects. You can have objects that contain other objects, and that's what we got here. The window object contains a keyboard object. So if you want to check what key is being pressed, you got to go window dot to get at Windows members, and then you go keyboard, and then dot key is pressed. And that's how that works. I know exactly the meme I'm going to use for this part of the video. Vintage 2007 meme. I'm like a meme sommelier. Sir, for this topic, allow me to recommend a 2007 exhibit meme. Its rich bouquet is perfect pairing for this. You get the point. I don't even get like wine tasting terminology. What the fuck is like mouthfeel? I mean, it feels like a goddamn liquid like any other wine. It's not like one day I had this wine and actually it was like a turkey breast in my mouth. Doesn't make any goddamn sense. Listen, the only mouthfeel I care about is the feel of your mouth around my hey! You can't say that on television. So yeah, anyways, the keyboard object lives inside of the Windows object's belly. And it makes sense when you think about it in Windows terms, because when you're programming Windows, and we'll get to this eventually, but keyboard input and mouse input is received through window messages. So it makes sense to put the keyboard object inside of the Windows object. But anyways, that's neither here nor there. So what we're doing here is we're setting the value of this variable. We're actually initializing it. And you might think this is kind of weird because normally you're used to seeing a variable being set to a value and condition takes true or false, but we're setting it to like a function. How do you set a boolean variable to a function that doesn't even make any sense? And we're not setting it to the function. This function here, let's bring up the tooltip, Shift Control Space. And here is the signature for the function. We can see it takes a single value here, unsigned car. We'll get to that later. But this is the important part. The first type name that comes up before the name of the function, that's the return value. This is the value that this function poops out when we call it. So when we call key is pressed, it's going to poop out a bool, and we're going to shove that bool into our bool box here. And then we're going to use that bool to control our if statement. Pretty fucking sweet. Now this is different than putPixel, because putPixel doesn't return shit. Its return value is void, and that means it's not returning jack or shit. What putPixel does is it has an effect on the state of the machine. It changes the graphics on the screen. So it just changes the state of the computer, but it doesn't return any values. Whereas key is pressed, it doesn't change anything, but it gets us some information. And we can store that information in a variable and then use it somewhere else. Use it. Now, you probably already guessed that this value here, it's actually a symbol, but this symbol here tells us what key we're checking. Key is pressed is going to check to see if a certain key has been pressed, and this parameter here is saying which key we want to check. Now, you might ask, where does this symbol come from? Where do we get this information, Chili? Well, that's a great question, and I'm glad you asked. If you go to the wiki and you go to the Chili framework, there's going to be a link to this in the tutorial page for this lesson. You go here, you've got all the documentation of the framework. And what we want is we want to look at keyboard. So we're going to go to keyboard. Here's a little overview. Click here to go to the main article. And let's look for what function we want. Key is pressed. Key is pressed. Here it is. Key is pressed. Check to see if a specific key is pressed. The function parameter is the virtual key code of the key. So this thing that we're passing is apparently a virtual key code, which is why it starts with VK. Let's learn more about this. Okay, so virtual key codes are a thing. You can read this yourself. I'm not going to read it to you. This isn't bedtime stories with Chili here. But yeah, VK space, VK shift, VK enter, these are all examples. And you can see the Microsoft documentation to see the full list of virtual key codes. And here they are. So here's all the virtual key codes and, you know, what keys that they represent. You can check this, you can learn all about it. Good times. Now, what we can do is we can just take this function call if we want, and we do want, and jam it directly into the if statement, to the expression that is evaluated for the if statement. And what's going to happen is when we do this, well, it's going to hit the if statement and it's going to evaluate the expression, meaning it's going to call this function. It's going to poop out a bool. Then depending on that bool, it's either going to execute this code or it's going to skip it. Now, so far, this flow control is it's not really more, it doesn't look like a branch. What it looks like more is like a detour. If it's true, you take the detour. If it's false, you skip the detour and keep going. We can make it a true branch by adding an else in here. And what this does is it is going to Well, basically, if the statement is true, it's going to execute this code. But if it's false, it's going to execute this code. So it's going to execute either or. Never both at the same time, and never neither. It's either going to do this one or this one. One or the other. Take your choice. So if I replace all the greens with 0 here, and I build that, we're going to get slightly different colors depending on what we have. So here we have whatever color this is, I forget. And if we press up, we get white. Not up, and it is this color. Magenta? I don't know. Now we can also chain if statements together. We can take this else, follow it by an if, and put another condition in here. So I'm just going to put another expression in here, and we're going to check down now. Down. And the way this works is it checks the first condition. If it's true, it executes this code and then leaves. If the first one is false, then it's going to check the second one. And if that's true, then it's going to execute that. Otherwise, it leaves. So it's never going to execute both A and B. It's either going to do A or B or neither. So these are mutually exclusive. And you can chain as many of these as you want. So this is, in a way, the way you could create like a 3-way branch or a 4-way branch or whatever. You can have your 3 ways, your 4 ways, whatever kinky shit you're into. I don't want to know. I don't want to kink shame you, man. You be you. And at the end, you can always put an else. And that means that if none of these are true, then this one will be executed. Just note that it checks these guys in order. First the top one, then if that's false, the second one, then this one. And if any of these become true, it's going to short circuit the rest of them. It's not even going to look at them. So there's definitely an order of precedence here. You can also put if statements inside of your if statements. And this is called nesting. Yo, dog, I heard you liked conditionals. I'm going to get a lot of mileage out of this meme. I know it. This is like, you know, in Sesame Street when it's like, this episode has been brought to you by the letter Z or whatever. This tutorial has been brought to you by the meme exhibit, Yo Dog. All right, so what we can do here, so now we've got 2 conditions. So it's going to check this one. Well, make a prediction. What do you think? How do you think this program works? I'm going to run it. And you see if I press up, nothing. If I press down, nothing. If I press up and down at the same time, I get magic. So yeah, it's going to check the first condition. And if it's true, it's going to execute this block. And in this block, it's going to check this condition. And if it's true, it's going to execute this block, which has our put pixels. So they both have to be true to execute this code. That's called nesting. We're going to be doing a lot of it. But yeah, that's if statements. And I think it's pretty powerful stuff. Conditional branching combined with input will allow you to make something that's interactive. And that's a big step towards being able to create an actual game. Now, I've shown a lot of different patterns and usages for the if statement here, but don't sweat it if you don't think you have your head around every single one of them, because we're going to be practicing this shit a ton. Just as long as you have like the basic idea, the gist of it, that's fine for now. You've got it. But now it's time for the homework. Everyone's favorite time, homework time. So what I want you guys to do now is I want you to make a program that does this. So you'll be able to control the cursor in any one of 9 positions like this. And you'll also be able to change its color by pressing a button. And you'll be able to change its shape by pressing a different button. And you can hold that button while you're changing the position. And you can also change the color and the shape at the same time. It's all good. Oh my God, oh, so much power. I'm drunk with power. But yeah, this is what I want you to do. And the controls are, use the arrow controls to control the position. Use control to change the color. And use shift to change the shape. You don't have to use this shape. You can come up with your own shape. Make like some kind of freaky shape, something funny. If you tweet it at me, then it might make it into the next episode, depending on how fast you are. But don't don't make dicks, because I don't think I can put dicks on YouTube. That'll probably get me in trouble. So, I mean, you can make dicks. I'll laugh at it, but I won't put it on the video. Now, you might think it's a little strange that the reticle is moving like it does on the screen. And that's an interesting thought to have. It's a good question to ask. But I will address that in the next episode. So for now, just put that out of your mind. Don't worry about it. But yeah, that'll about do it for today's tutorial. Thanks for watching, and as always, thanks for your support. If you liked the video, please click the like button. It helps a lot. And consider following me on Twitter. Sometimes I give advanced notification for when a new video might be coming out or whatever. It's all good, and I'll see you later.